Now this is question number 58. Question number 58, again based on assertion and reason. So if you just look at statement 1, property of function fx is given, that is f of x by y equals to f of x minus f of y. So it seems to be a log function, because log of a by b is log a minus log b. But just let's derive it using the approach we had discussed in the class, that we differentiate this with respect to x taking y constant, right? So we get this derivative of this is f dash x by y into derivative of x by y, as we have taken y constant. So we differentiate, when we differentiate x by y, it is 1 by y, because we differentiate x taking y constant. And right hand side, derivative of fx is f dash x, and derivative of f dash y is 0, because we have taken y constant, so derivative is 0. Now after differentiating, we want to generate a differential equation in x or differential equation in y. Basically we have to remove one of the two variables, either we remove x or we remove y, and we have to make sure that finally what we should get should be the differential equation, should involve derivative term. So what we do here is we replace y equal to x. So you can see, we replace y equal to x, and we replace y equal to x. You can see this becomes f dash 1, and we replace this y by x. So it's a differential equation. You can see here it's a differential equation where derivative f dash x equals to of the type k by x. Now we integrate this to find fx. We integrate this, integral of f dash x is fx, and integral of 1 by x is log mod x. We get this fx. And also in the question it is given that limit x approaches 0, f of 1 plus x over x is 3. So we replace fx here and take the limiting value at x equal to 0. What we are getting is c equal to, what we are getting here is like this limiting value is 1. So we get f dash 1 equal to 3 minus c, f dash 1 equal to 3 minus c from this place. And we can look at here that if we put x equal to 1 and y equal to 1 in this property, we get f1 equal to 0. You put x equal to 1, y equal to 1, this becomes f1, and this is f1 minus f1, that is 0. So f1 is 0, and using f1 equal to 0, we can find the value of c. We replace x equal to 1 and f1 equal to 1. I put x equal to 1 and f1 is 1. What we get is c equal to 0. So now this is the fx function. Fx is 3 into log of mod x. Now we, we could have directly obtained fx using the property of log, assuming, as we know, f of x by y is a property of log. This is a log property. So we could have, in the starting, we could have assumed fx equals to k log, maybe k log x plus c, right? And we would have obtained c and k. Now once we have fx, we can find the area bounded between fx and this line, right? We're supposed to find this area, and for that we apply right minus left formula, fy minus dy formula. This is 0, so right minus left. For that we need to express x as a function of y, right? X as a function of y. So x as a function of y is e to the power y by 3. We integrate this from minus infinity to 3. To find this shaded area, we are integrating right minus left, this exponential curve x in terms of y, minus 0 from minus infinity to 3, and on integration we get area equal to 3. So this shows that statement 1 is correct. And if you look at statement 2, we already got fx in previous part, that is 3 log mod x. We differentiate fx, the derivative is 3 into derivative of log mod x is 1 by mod x into derivative of mod x, and derivative of mod x is mod x by x. Using this formula, whenever we have to, if you differentiate mod of fx, this is equals to fx by x, a mod of fx by x into f dash x. This is the formula we use when if we have to differentiate mod of fx. Mod of fx by fx into f dash x. So to differentiate mod of x, we have done this. Mod of x into divided by x into 1 into derivative of x, that is 1. So f dash x is 3 by x. Second derivative is minus 3 by x square. And as second derivative is negative, you can see second derivative is negative. It means the shape of fx curve is throughout convex. Fx is convex upwards, or we can say concave down. So statement 2 is also correct. But statement 1 is correct, statement 2 is correct. Now we have to decide whether answer is B or answer is A. Answer is B when using statement 2 we cannot prove statement 1. Statement 2 cannot be used to prove statement 1, or there is no use of statement 2 to prove statement 1. Then we say correct choice is B choice. But if using statement 2 we can prove statement 1, from statement 2 we can prove statement 1, or statement 2 can be used to prove statement 1, then answer is A. If statement 2 cannot be used to prove statement 1, then answer is B. Now if you look at statement 2, it says that second derivative is negative, that is shape is convex upwards. Now by taking shape convex upwards, we cannot find area bounded by curve and y equal to 3 line. There's no way we can calculate this area bounded equal to 3, right? So using this thing, using convexity has nothing to do with area bounded. So that is why statement 1 is, that is why answer is B, because statement 1 is correct, statement 2 is correct, but using statement 2, statement 1 cannot be obtained. So statement 2 is not the correct reason for statement 1. So hence the answer is B.